Hi people, notes 4.8 are on finding key features of parabolas in all forms. And if you notice, it says refer to the summary sheet for quadratic relations. So if you look here, we have all of the information that we need for our quadratic relations. So you've got all the different forms. You've got factored form, vertex form, standard form, tells you what the equations look like, and also tells you how to find all of the key features. So anytime you ever need to look at that, you have that available to you. Okay, I'm going to use this to help us do the key features that we have right here. So in question number 1, it says use the key features of a parabola to graph the quadratic relation below. The first thing I want to do is find the roots. So let's go ahead and find the roots. Whenever I want to find a root, I always set the equation equal to 0. So I'm going to say 0 equals 3 times x minus 2 times x plus 4. Well, what that means here is that my two roots are either going to be positive 2 or negative 4. So these are my two roots, 2 and negative 4. If you look right here, it tells you in factored form, you're going to set each factor equal to 0, and that x would either equal r or s. Then the next thing we have is the axis of symmetry, and that tells us to average the roots or the zeros when it's in this form. Because always wherever the roots are, if my roots are at 2 and negative 4 right here, the axis of symmetry would have to be halfway in between these two values right here. So let's go ahead and find the axis of symmetry. And you know what? Let's label this that this is the work for the roots. So let's find the axis of symmetry. So I'm going to average my two values. So I'm going to average 2 and negative 4 by adding them together, dividing it by 2. So I get negative 2 over 2, which is negative 1. So here our axis of symmetry is negative 1, which should make sense because negative 1 is 3 away from 2 and also 3 away from negative 4. And then I need to also find the vertex. And just a reminder, the vertex happens on the axis of symmetry. So let's see what this says right here. Plug in the axis of symmetry into the x in the equation of the parabola to find the corresponding y value. And that corresponding y value is your optimal value. So we're just finding our optimal value right here. So right here, our equation would be y equals 3 times x minus 2 times x plus 4. But instead of x, I'm going to now replace it with this negative 1 that we got from our axis of symmetry. So I'm going to color code this in orange so you can see that we got it from this axis of symmetry that we have right here. And then I'm just going to go ahead and evaluate. So it's going to be y equals 3 times negative 3 times positive 3. And then when I multiply this whole thing together, I get negative 27. So here my vertex would be at negative 1, negative 27. Okay, and then the last thing that we need to find is our y-intercept. So to find our y-intercept, it always happens when x is 0, right? Our y-intercept always happens on the y-axis. That's where x is 0. So here, to find the y-intercept, plug 0 in for x into the equation of the parabola. Just like here, we plugged in negative 1 for x right here into the equation of the parabola. We're going to plug in 0. So I'm going to write out the equation of the parabola. And every time I see an x, I'm going to replace it with a 0. So I'm going to say 3 times 0 minus 2 times 0 plus 4. And when I go ahead and evaluate this, this becomes 3 times negative 2 times positive 4, which gives us negative 24. So that means that my vertex would be 0, negative 24. Do not forget, I said my vertex, but I meant to say my y-intercept. Do not forget to write your y-intercept as a coordinate because an intercept is always a coordinate. Okay, so now we're going to use that key information to go ahead and graph out our parabola. And I'm going to place my x-axis up a little bit higher because my vertex and my y-intercept are both negative values for the y values, and my parabola opens up, which means that this is going to be the lowest value that it's going to reach right here. And because these are negative values, that's going to help me out to realize that I need to have my x-axis up a little bit higher so I have enough space for those negative values. So I'll put my x-axis like right here, and then I'll put my y-axis right in the middle. And don't forget to label your axes right here. And I think it would be okay for me to go by every other is a whole. So pretty much each one is a half right here, because that gives me enough space to go out to my roots. For my y-axis, I have to make sure that I can get as low as negative 27. So here, I'm going to count up how many values I have here. And I have 17 values. I think if I go by twos, that'll be a good scale right here. So this would be negative 2, this would be negative 4. I'm not going to label every single one. So negative 6, I didn't label it. Then I've got negative 8, negative 10, negative 12, negative 14, negative 16, skip the negative 18, skip the negative 22, and I've got negative 28, and I think that that is sufficient. So now I'm going to go ahead and graph out my roots. So my roots are at positive 2 and at negative 4. My axis of symmetry is at x equals negative 1. My vertex is going to be at negative 1, negative 27. And my y-intercept is going to be at 0, negative 24. And then I'm also going to draw the symmetrical y-intercept value on the other side as well. So I also know that at negative 2, it will also correspond with negative 24. And then I can just connect those dots. And this is how I found my parabola's key features in factored form. All right, in our next example, we're asked to use key features of a parabola to graph our relation below. This time our relation is in vertex form. And I guess maybe we should have labeled our top one right here that this one is in factored form. Okay, so let's go ahead and talk about how to do this right here. So the first thing I want to do is find my roots. And my roots will still occur when y is 0. So I'm going to write 0 equals negative 1/2 times x minus 4 squared plus 3. And I could expand this whole thing out, but I don't have to, because all I have to do here is just isolate that perfect square. So I'm going to move the 3 over, so I get negative 3. And then I'm going to multiply both sides by negative 2, because when I multiply this side by negative 2, this negative and this negative cancel and the 2's cancel. So all I have left over is a 1. And I don't have to put that 1 there. It's just x minus 4 squared. And then on the other side right here, negative 2 times negative 3 is just positive 6. Then I can go ahead and square root both sides. So I get plus or minus the square root of 6 is equal to x minus 4. Now I cannot square root 6 evenly. So I'm going to leave it as plus or minus the square root of 6 for right now until I'm ready to actually figure out what these numbers are. Because if I'm going to graph it out right here, having it as a square root isn't going to be helpful. So let's go ahead and add the 4. So I end up getting 4 plus or minus the square root of 6, which means that my two answers are either going to be 4 plus the square root of 6 or 4 minus the square root of 6. So let's type that into our calculators and see what we get. So 4 plus the square root of 6, I'm going to just type that in. And here I end up getting let's round this to the nearest 10th. So this is 6.4, okay? And then I'm going to do 4 minus the square root of 6. Same thing, I'm going to round this to the nearest 10th, and I get 1.6. So my two roots are 6.4 and 1.6. Let's look at what this says right here. For vertex form, set y equal to 0 and solve by isolating the perfect square binomial and then square rooting, which is exactly what we did. Now, let's talk about the vertex next, because that's so much easier in vertex form, and then we'll use that to help us find the axis of symmetry. So don't forget that vertex form tells us the vertex, so our vertex would just be HK. So here we know that our vertex is going to have to be, so first of all, let's write this down as 1.6 and 6.4. We know here that our vertex is going to have to be 4, positive 4, because that's our H value, and then positive 3, because that is our K value. And then we also know that our axis of symmetry is going to be at x equals 4, because it's always going to be whatever the x value is in the vertex. And if you look right here, it's always going to be x equals h, and h in our example here is 4. Okay, and then lastly, I need to find the y-intercept. To find the y-intercept, I'm going to do exactly the same thing that we have always done. I just plug in 0 into my equation for x. So here's my equation. And instead of x, I'm going to replace it with a 0. And this right here, 0 minus 4 is negative 4. So I'm going to square negative 4. And then negative 4 squared is 16. And then half of 16 is 8, but this is negative half of 16, so I get negative 8. Add 3 to it, I get negative 5. So my y-intercept is at 0, negative 5. And now we have enough information to be able to graph out our parabola. Okay, so in our last example, we're asked to use the key features of a parabola to graph the quadratic relation below. And this time we have this in standard form, because if you notice, it's y equals ax squared plus bx plus c. So we've got this in standard form. So if you look and see to find the roots in standard form right here, so we've got standard form right here. To find the roots, we set y equal to 0, and we solve by either factoring, completing the square, or the quadratic formula. Now, if it is possible to factor, that's what we're going to do. So let's start by trying to see if we can factor. So I'm going to replace the y with 0. So here I'm going to say 0 equals negative 4x squared plus 10x minus 4. And I'm going to try to factor. Now, the first question I always ask myself whenever I factor is there GCF? And there is. There's a 2 in common with all three of these numbers. They're all divisible by 2. And because the leading coefficient is negative, I'm going to factor out a negative 2. Now, when I do that, here I get 2x squared. Negative 4x squared divided by negative 2 is positive 2x squared. 10x divided by negative 2 is negative 5x. And then negative 4 divided by negative 2 is positive 2. So then I'm going to try to see if I can factor this any further. So I'm going to use guess and check just because it's quicker. I know that this has to be 2x and x because 2 times 1 are the only numbers that multiply together to give me 2. And then here for the last numbers, same thing, have to multiply together to give me 2 as well. So one little trick that will be helpful to you is because there's nothing in common with these 3 terms right here, then I should not have expressions that have anything in common. So I shouldn't want to put a 2 here because if you notice here, these have a 2 in common, but the original expression that I'm trying to factor has nothing in common. So I don't want to have anything that would have GCFs inside of the brackets here. So I'll try to place the 1 here and the 2 here. This gives me 4x. This gives me 1x. Both are negative, so the negative 1 and negative 4 would give us negative 5, which is exactly what I'm looking for. So this will be a minus 1 and a minus 2, and we are good to go for our factoring. Now, to solve for our roots, remember we set each factor equal to 0. So we set negative 2 equal to 0, which will never work. We set 2x minus 1 equal to 0, and we set x minus 2 equals to 0. So now for this one, in order to solve for x, we have to add the 1 to both sides, and then we have to divide by 2. So here, x is 1/2. And then here, to solve for our root here, we would do x equals 2. Just add the 2 to both sides. So that means that my roots are 1/2, positive 1/2, and positive 2. Okay, now let's talk about how to find the axis of symmetry. So now that we know the roots, we have 2 options. We can either average the roots, or we could use this formula right here, which will be useful, which is to just do x equals negative b over 2a. So let's go ahead and write that down. So here we've got axis of symmetry, and the formula for the axis of symmetry is x equals negative b over 2a. And right here, I'm going to use this original equation right here because I want to find the axis of symmetry of this. So the b value is 10, so I'm going to do negative 10 over 2 times a, which is negative 4. So here I get negative 10 over negative 8, which becomes a positive 10 over 8, and it turns into 5 over 4, or 1.25. So here I'm going to say x equals 1.25, mainly because it's easier for me to graph that out. But also, if I wanted to do my axis of symmetry by just averaging my 2 roots, I could have just taken 1/2 plus 2 and then divided that by 2. And 1/2 plus 2 is 2.5. Divide that by 2, I get 1.25. Okay, now to find the vertex, where I take my axis of symmetry, which is x equals 1.25, and I plug that into the equation for the parabola. So every time I see an x, I'm going to replace it with 1.25. Now, the skill that we're working on is not calculating, but just identifying key features of our parabolas. So I'm going to literally type this in exactly how I see it. So -4 times 1.25 squared plus 10 times 1.25. And then I'm going to write down the -4 at the end. And here I get 2.25. So here y is 2.25, which means that my vertex right here would be 1.25, 2.25. Okay, and then lastly, I have to find my y-intercept. Now, for my y-intercept right here, this tells us that the y-intercept will happen at 0c. But let's talk about why it happens at 0c. So here, remember, our y-intercept will always happen when x is 0. So here, I would do y equals a times 0 squared, no matter what a is, plus b times 0, no matter what b is, plus c. And this cancels, and all I have left over is the c. So here, the y-intercept is going to be at c. So here, my y-intercept will be at the c value, which is -4. So it would be 0, -4. But if you want to show the workout, it's nice and easy. Let's just get this out of the way right here. It would just be y equals -4 times 0 squared plus 10 times 0 minus 4. Cancel, cancel, and I get -4. So that is my y-intercept. So let's go ahead and graph this all out. So for my x-axis, I'm going to go by halves. So here's 0, this would be 1 whole, this would be 2, this would be 3, this would be 4, and then I'll do the same thing on the other side. And for my x-axis, or sorry, for my y-axis, I'm going to do the exact same thing. I'm going to go by halves. So here's 3, here's 2, here's 1, -1, -2, -3, -4, and -5. Okay, so my first root that I know is at 1/2, and the other root that I know is at 2. Okay, I also know that my axis of symmetry is going to be at x equals 1.25. So it's going to be right here, halfway between 1.5 and 1.5. My vertex is going to be on this line right here at 2.25. So I'm going to go to 1.25, 2.25, 1.25, and 2.25, and I can say it's approximately right here. So here's my vertex. And then my y-intercept is at 0, -4, and then I'm just going to do my symmetrical point on the other side. So this right here is 1.25 away, so I'm going to go another 1.25 away, and I end up at 2.5. And then I can just connect the dots. And this right here is my parabola. And that's how you get all of this information using all the different forms that we have here. So let me just write down here that this is standard form. All right, and that's it for this video. Let me know if you have any questions. Otherwise, I'll see you in class. Have a good day. Bye.